Welcome to Learn Rust. I'm Reese, and in the last video we explored the what and why of Rust. In this video, we'll create our first Rust program. As you know, teachers tend to use outlines. For much of this series, my outline will be the Rust book. So the code and order of topics may be exactly the same, if not similar. I anticipate deviating and using other resources as I deem necessary, partly to accommodate beginners as well as others coming from other languages. You know, my first language was C++, so based on what we learned in the last video, there's no reason why your first language can't be Rust, or third, or 12th, whatever your background is. I don't care, I'm just happy you're here. Furthermore, I need an outlet to avenge my past tutelage. What's that mean? Well, when I started out, there are topics that took me months to internalize, but in retrospect, I firmly believe they would have only taken days, hours, or even minutes had I received the right instruction. That is the standard of instruction I want for you. And if you ever feel this isn't the case, please let me know in the comments. Anyway, first things first, regarding your development environment, it may need some tuning so you can use Rust. If you're on Windows, first you need to download and install Microsoft's build tools. Then you need to install the Rustup utility by following some instructions on Rust's website. The links are in the description. Linux and Mac users can install Rustup by opening the terminal and entering the following command. curl-proto for the protocol, which we want to specify as HTTPS, so it's encrypted specifically with TLS v1.2, version 1.2. And we're going to target this domain, sh.rustup.rs. And we're going to pass the silent flag to it, meaning there's no progress bar, and the show error flag, in case there's an error, and the lowercase f, which means to silently fail on server errors. So that way if something goes wrong, we don't get HTML of a 404 page. Then we pipe that output into sh, the shell command language, so that it executes it. And we press enter. Now, of course, I already have Rustup, so, I'm not going to try to install it again. Now, in your case, after installation, no matter what operating system you use, it's a good idea to run Rustup update. This ensures that you've got the latest version. So while Linux and Mac users may already have the terminal open, as I do, Windows users can open PowerShell and run the same command. So let's press enter. And as you can see, my stuff's unchanged because it's already up to date. Now, if you experience some kind of weird error or problem running this, you may want to try running the following command, rustup install stable. Okay, and then you might want to run rustup default stable. You may have to do some troubleshooting. If you're on Windows and experiencing issues, it's possible that Rust isn't yet defined in your path variable. Otherwise, you may have to consult the official Discord, forum, and/or Stack Overflow. There are links to these in the description. One more thing we want to do just to ensure that your Rustup installation is right is run rustup --version. Okay, and of course, my version looks fine. This is what this should look like. Another thing, if you're cut off from the internet and need access to Rust documentation, do not worry. You can run rustup doc. This opens the local Rust documentation. Now, let's create a directory where we can learn Rust together, a sandbox if you will. On Linux, Mac, and Windows PowerShell, we can run makedir, make directory, sandbox. Then we can press enter and change into that newly created directory with change directory, sandbox. Alright, so now we're in the sandbox directory. Now actually, for the sake of organization, we may want to create another directory, make directory Rust. This will be for your Rust projects, and then of course we'll change into the Rust directory. We'll work from this subdirectory just in case you want to use the root sandbox directory for learning other things such as shell scripting. You need, at the very least, a text editor to write code. I encourage you to use whatever you're comfortable with. Personally, since I write code in various languages, I've found Visual Studio Code to be the most accommodating for my needs. It supports various extensions such as the Rust language server extension, which I strongly recommend you install. In fact, we'll install it right now. Boom, it's done. Even if you're using a different editor, there's probably an easy way to find and install the language server support. It's useful for a variety of things like code completion, jumping around between code blocks, types, and documentation just from hovering over text, etc. It even supports universal formatting through Rust FMT, Rust format. This ensures that Rust developers use consistent style, mainly regarding the use of whitespace in their code. There's various other extensions you may be interested in, but one of my favorites is called amVim. I don't recommend it though, unless you're familiar with Vim. You see, I don't like having to move my hands off the keyboard when I'm programming to point and click on stuff. Vim is a text editor with clever key bindings to keep you from using your mouse much, if at all. So the amVim extension emulates Vim key bindings within Visual Studio Code, while preserving common hotkeys such as Ctrl-S for saving and even allowing for code's brilliant multi-line editing. You may consider learning VI or Vim if this intrigues you, but it can take time to adjust, and I don't want to overwhelm you. Just keep in mind as we progress through the series that hotkeys can not only save you time, but also make you more comfortable. I am by no means a Vim master, but I can confidently say that I reap its benefits every day. Now, let's create a file called hello_world.rs. With Windows PowerShell, you can run ni file hello_world.rs. RS is the preferred extension for Rust source files. Ni,
the knights who say ni demand a sacrifice,
is shorthand for new item, and I is shorthand for item type, which of course we specify as a file, and the file name is again hello_world.rs. You'll note it's common to use so-called snake case when naming things in Rust, which you can read about on Wikipedia. Basically, it's all lowercase, and instead of spaces, you use underscores. It's a style thing. With Linux and Mac, all you have to do is type touch, which creates files. So touch hello_world.rs. Press enter. And with all of that out of the way, assuming your Rust tooling works and you have an adequate text editor, we're ready for the rite of passage. In other words, the ceremonial Hello World program. And what's it do? It prints Hello World in the terminal, that's all. But I'm not going to explain it really, we're just going to write the code that does the thing by editing the file we just created. We'll explore how the code works and many other things over the next few videos because I want you to have a solid understanding of what's going on. So, to edit this with Visual Studio Code, I'm simply going to type code hello_world.rs and press enter. In your text editor, type the following and save it. We'll compile this file soon, but first let's discuss compilation. Compilation simply means to convert one language into another. Rust is a so-called human-readable language, meaning it's easy for humans to understand and modify. I doubt you want to code in all ones and zeros, so that's kind of why these programming languages exist. Rust uses the LLVM compiler infrastructure project to compile code. LLVM stands for Language Independent Intermediate Representation. I know, it's a mouthful. So, language independent means it's agnostic to the language that uses it. So that includes Ada, C#, CUDA, Objective-C, etc. Intermediate representation, in the context of compilation, simply means it's somewhere between human readability and assembly. Assembly is essentially symbolic machine code. You may be wondering why. Like, why not just go straight from Rust to assembly or machine code? Well, an assembly language is designed for a specific computer architecture, and chances are you want your program to work on multiple platforms, multiple architectures. Otherwise, you could end up writing a program that works on your computer, but when you send it to your friend, it doesn't work on theirs. Hence, the intermediate representation, IR, helps ensure platform independence, among other things. And if you haven't fallen asleep and still want to know more about Rust compilation, check out the Guide to Rust C Development. There's a link in the description. Now, let's compile our program. You can simply run rustc hello-world.rs and pat yourself on the back if you figured out that rustc means Rust compiler. Press enter, the file compiles. Finally, we need to execute our program. With Windows PowerShell, you simply need to type ./hello-world.exe. For Linux and Mac, we instead run ./hello world, and there's no .exe on the end, that's just a Windows thing. And to be clear, with Windows, you use backslashes because Microsoft had to be different. For all the other sane operating systems, we use /. And from this point forward, I will no longer share the Windows-ized commands. You can figure it out yourself at this point. I use Linux, and the commands I share from this point forward should be compatible with any Linux derivative and most likely Mac as well. Anyway, let's press enter, and there you have it. It works. Well, I mean, it works at least on my computer. I don't know about yours. I hope it does, but if it doesn't, you may have to retrace your steps. So we did it. Our little program just greeted the world. But there's so much more in store for you. In the next video, I'll cover how to use Cargo, Rust's package manager. I hope you join me. And hey, please like and subscribe so I know how I'm doing. Thanks.